So far we've solved a quadratic equation, which of course has this form, either by factoring if it was factorable, by square rooting both sides if it was in a correct form, or by completing the square and then getting it ready to square root both sides. Now we're going to do it by the quadratic formula. So what is the quadratic formula? It's basically a formula that helps us find solutions to this quadratic equation rather quickly by plugging in numbers into a formula and getting solutions. How to get the quadratic formula? Well, we get it by completing the square method used on this general equation. So let's get started. We're going to start with this general quadratic equation. We're going to move the constant to the other side. Remember, leave some space because you're doing completing the square. The leading coefficient is a. We want it to be 1, so we divide everybody by a. Now the leading coefficient is 1, and we have negative c over a. Now we're ready to do the half business from completing the square. So we're going to take half of the coefficient of x, multiply across b over 2a. Remember, we save this guy, and then we immediately take it and square it, so we get b squared over 4a squared, and we use this guy. Well, how do we use it? We add it to both sides, and when we do that, we can factor the left side into two binomials that look identical, x and x. And remember, the guy we saved is always the second term in my binomial, and since it's completing the square, both binomials look the same. On the right, I need to get a common denominator, so I'm going to multiply top and bottom by, I guess, a 4a to make the denominators look the same, so I'm able to add those two guys. That's going to be negative 4ac over 4a squared and b squared over 4a squared. So I have 4a squared downstairs, same denominator, and up above, just put the numerators together because they're not like terms and you cannot add them. Now I am almost there. I have a binomial squared equals, I'm going to put the b squared first because I just like it to start with a positive term. Notice now I'm ready to square root both sides because now it looks like the goal that I was after to get a binomial squared. So I have x plus b over 2a that pops out, and then I have plus or minus b squared minus 4ac up on top, and the bottom pops out a 2 and an a. There's a link here, so I can't have a b pop out because the b squared is linked with the 4ac. For the same reason, I cannot have a 2 pop out. Now I'm going to isolate x, so move this to the other side, and I have x equals negative b over 2a plus or minus this business. And since they have a common denominator, I can put them together, negative b plus or minus square root of b squared minus 4ac all over 2a. And this, most of you probably remember as the quadratic formula. But basically where it comes from is just completing the square. So if you have the quadratic formula memorized, you basically plug in the a, b, and c values from your quadratic equation and get your two solutions after you simplify. So this is the main thing we'll be using in this section, the quadratic formula. So we're going to solve using the quadratic formula. First thing I have to do is put this in standard form. You can't get your a, b, and c unless you have the 0 on one side. So a is 2, b is 11, and c is negative 6. Make sure you pay attention to signs. Formula says x is equal to negative b plus or minus square root of b squared minus 4ac all over 2a, so I'm going to go plug those in. Plug everything in into b, into b, into a, into c, and into a, and don't do anything in your head to make mistakes. Now go simplify these. So negative times negative is a positive, so I get a positive 48 and added 169, which is a perfect square. So I have negative 11 plus or minus 13 pops out over 4, and that'll give me two answers, negative 11 plus 13 over 4, or negative 11 minus 13 over 4. Once I simplify those, I get a half and negative 6. So those are my two solutions to this quadratic equation. In other words, if I were looking at this parabola, these two would be the two x-intercepts. Let's solve this using the quadratic formula. I have to get it in standard form first, so I'm going to distribute. And then I'm going to combine like terms. And I'm going to move the 5 while I'm at it to get my 0. So I have my A to be 1, my B to be 2, and my C to be negative 5. Then I go plug them in. So I have negative 2 plus or minus 2 squared minus 4. A is 1 and C is negative 5, all over 2 times A. So I simplify everything and I'm up to here. But 24 could be further simplified. So I'm going to break up 24 as 4 times 6. And I have all of that over 2. This one pops out at 2. The 6 remains. And now I see that they're all divisible by 2. So I really have negative 1 plus or minus just a 1 radical 6 as my two solutions. Next thing we're going to look at is analyzing the discriminant in the quadratic formula, which is really just this piece. So we're just going to analyze some signs of the discriminant. B squared minus 4AC, if this is positive, I'm going to get two real solutions, like the examples we've just done. If the discriminant is less than 0, in other words negative, I'm going to get two complex solutions out of my quadratic equation. And the last case, if b squared minus 4ac is equal to 0, then I'm going to get one real solution because this piece completely disappears and I have negative b over 2a, which would be the vertex of the parabola, being my only solution, and if I'm thinking of it graphically, also that one x-intercept only. So let's look at an example. It says use the discriminant to analyze whether this parabola has 1, 2, or no x-intercepts. In other words, when I make y equal to 0 to find the x-intercepts, instead of going and finding the x-intercepts, let's just use the discriminant b squared minus 4ac to predict what might happen, what kind of x-intercepts I may have. So there's a, b, and c. So b is 10 squared minus 4, a is negative 3, and c is negative 5. Let's see what that gives me. 100. That's going to give me a positive 12 times a negative 5. So 100 minus 60, which looks like it gives me 40, and as long as that's a positive number, it looks like I'm going to have two real solutions, so I'm going to have two x-intercepts for this parabola if I go look at it. Let's look at another example. Given the graph of this parabola, whatever a, b, and c may be, we don't know, here's the parabola, is a positive or negative? Well, since this thing opens up, a must be positive. That's all we have to answer. A is positive because my parabola opens up. Part B says solve this equation. Well, if I'm setting the equation equal to 0, I'm making y equal to 0. So I'm looking for x-intercepts in my graph. Well, when I go to the x-axis, there's no way this parabola is ever going to touch the x-axis because it keeps going up and up and up in the other direction. So there are no x-intercepts, and if there are no x-intercepts, this equation has no real solutions because I wasn't able to find where it crosses the x-axis. Part C says, is the discriminant positive or negative? Well, if I'm looking at the discriminant, which is b squared minus 4ac, and if I'm getting no solutions, because that's what the graph tells me and that's what part B tells me, If I have no x-intercepts, that must mean that b squared minus 4ac is negative, since I have no real solutions coming out of the equation in part B. So even though I don't know what A, B, and C are, I can tell all of this information visually. First of all, my parabola opens up. Second, there are no x-intercepts, and if there are no x-intercepts, that means my equation doesn't have real solutions. If it doesn't have real solutions, it must have complex solutions. If it has complex solutions, then that must mean that the discriminant is negative, because I don't see any x-intercepts. Solve by any method. So, any method, if I can factor easily, I always choose that first, and it looks like if I put this in standard form, it is factorable, and if something is factorable, might as well go ahead and pop out your solutions right away. So this I chose to do by factoring, just because it was an easy problem to factor. Part B, again, I'm not going to use the quadratic formula. A, B, and C, why go through that? If I just isolate the x squared piece, notice what happens. I can easily use the square root property and get x to be plus or minus 3. So I did this by square root property just because it was easier to do it that way. Now part C, if it's any method and it looks a little ugly, I'm just going to choose to go ahead and use the quadratic formula, because quadratic formula basically comes from completing the square anyway, so that was my third option usually, but now the quadratic formula makes things easier for me. I don't like those fractions because it's an equation. I'm going to multiply everybody by the LCD, which is 4. So I get a 2x squared plus a 3x equals negative 4. I got to put it in standard form. 2x squared plus 3x plus 4 equals the 0 I need. So now I have my A to be 2, my B to be 3, and my C to be 4, and I'm going to go plug them in. So I got them plugged in. Now I'm going to go ahead and simplify. Okay, and it looks like I get a 9 minus 32, which is going to be a negative 23. And notice that's going to create complex solutions. So I have negative 3 plus or minus, I'm going to pull out an I. The 23 is going to remain all over 4. There's nothing more to simplify, so I ended up with 2 complex solutions, which means if I'm looking at the graph of this parabola, if I set this equal to y equal to my parabola, then my graph will have no x-intercepts because I ended up with complex solutions. So solve by any method. I'm going to go ahead and use the quadratic formula again because I would rather just plug in some values really quickly, but I need to get everything in standard form first and get a 0 on one side. So 5x squared plus 13x plus 6, actually minus 13x. So that my A is 5, my B is negative 13, and my C is 6. I'm going to go plug those in. So we plug them in. Notice it's a negative part of the quadratic formula and then a negative also part of my B. So double negatives are going to make a positive. Okay, looking good so far. 169 minus 120, that gives me a 49, which is a perfect square. So I have 13 plus or minus 7 popping out over 10. And that's going to give me 2 solutions. So once I simplify each piece, I get 2 solutions, 10 and 3/5. So those must be my x-intercepts if I were to graph this and make it look like a parabola. And since I have 2 real solutions and they both look like rational numbers and not any square roots and irrationals involved, it means this problem was factorable to begin with, but I just went ahead and used the quadratic formula.